Okay, first we will look at the conjugated diene system, and make sure you have a pen and notebook so that you can jot down, because this subtopic is very confusing, a bit confusing, but don't worry, you can catch up. Okay, for conjugated diene system, the parent value, it has two types, which are homoannular diene and heteroannular diene. For homoannular diene, it is the cyclic diene having conjugated double bond in the same ring. Okay, for now, what is diene? Actually, diene is the double bond. Okay, the compound that contain double bond, two double bond in one ring. Okay, this is what we call the aromatic ring. So in this aromatic ring, it has two double bond. We call it as a diene. And what is the conjugated double bond? So conjugated double bond means that it has two compound in pairs. Okay, compound in pairs. So conjugated means that um, has two double bonds separated by single bond. Okay, we can see that this one is double bond. So this is the single bond separated by single bond to meet the another double bond. So the value for homoannular is 253 nanometer based on the table. So you don't need to memorize the value, and you just need to know where to apply the value. Okay. For heteroannular, it is the cyclic diene having conjugated double bond in different ring. So we can see that here we have one double bond separated by the single bond to meet the another double bond. So we call it as the heteroannular. This one is the parent value contain double bond in different ring. So the value for parent value here is 217 nanometer. So we have one double bond in this compound and another double bond in this compound. And it is actually the conjugation of diene present in two different rings. Okay, please bear in your mind diene is two double bond. In order for you to determine the lambda max, you also need to determine the value for various alkyl substituents or ring residue, double bond extending conjugation, and also the polar group such as chlorine, bromine, and etc., which are added to the basic value for the compound. Okay, now we look at the other terms, which is endocyclic double bond. Endocyclic double bond is double bond that present in a ring. So endocyclic double bond, just ignore the value because it's a bit confusing, so we tend to ignore the value. Alright, the most important thing is the exocyclic double bond. It is double bond in which one of the doubly bonded atom is a part of a ring system. Now look at the example. We have compound A and B. So how can we determine the exocyclic double bond? For you to determine the exocyclic double bond, you need to draw this structure first. Contain A and B compound. So you must use your hand to cover one of the compound. Let's say if you want to determine the exocyclic double bond in B, so you need to cover compound A with your hand. Let me show you. Okay, you want to determine the exocyclic double bond present in B first. So you need to cover compound A first, right? So outside the B compound, if you want to find the exocyclic double bond in outside A, okay, you want to find the exocyclic double bond outside A compound. Okay, this one is compound A. So is there any exocyclic double bond outside compound A? So you must look at the double bond here, double bond here, this one double bond, that attached to the compound A. Okay? Yang awak kena tengok compound dalam yang di luar A ni, dia attach, double bond yang attach dengan structure A ni. So there is one double bond exists outside the A compound, which are here. Okay, this one. So we have one exocyclic double bond. The value for exocyclic double bond is 5. Okay, now we look at the outside compound B. So you need to cover A. Okay, cover the A compound. Now look at outside B compound. Is there any double bond attached to this ring? Okay, this one has 1, 2, 3, 4, 5, 6 ring. Is there any double bond attached to this body of the compound? So there is no attachment of double bond. As we can see, the double bond is located here. It is not attached to this structure B compound, structure B. Okay, there is no double bond attached to this structure. So we can say that outside the B compound, there is no exocyclic double bond. So A have one exocyclic double bond outside the ring, while B has no exocyclic double bond. So in this structure, A and B compound ni, dalam structure ni, we have one exocyclic double bond. The value is 5. Let's say if you have two bond of exocyclic double bond, 2 bond exocyclic, so you must multiply with 2. So 5 times 2 dapatlah 10 kalau ada 2. Dalam kes ni dia hanya ada 1 exocyclic double bond. Now we look at the double bond extension to diene system. Okay, it is the conjugated double bond in a molecule, which is the single and double bond alternate. Okay, for this case, now we want to find whether this compound has double bond extension to diene system. Means that we have one double bond here, separated by a single bond, it has another double bond. So this is considered at double bond extension to diene system. So the value is 330 nanometer. For this example, second example, we have two conjugated double bond. First is here. Let me show you. First, we have this compound, right? We have this compound. We have double bond, single bond, and double bond. And another one is starting from here to here. Okay. Double bond, single bond, double bond. So we have two conjugated double bond extension to the diene system. So 30 times with 2. We have 16 nanometer double bond extension to the diene system. So the conclusion is if you have two double bonds separated by a single bond here, it has 30 nanometer. And it will have the value of 30 nanometer. So let's say if you have 1, 2, 3 double bond, double bond like this, which is only separated by single bond. So you will get 60 nanometer of double bond extension. Let's say if there is another compound here and also have another double bond present here. So you need to multiply with 3. 30 times with 3, which is 90 nanometer. Macam tu. So another value that you need to determine is isochrome. We have O alkyl, the value is 6, and S alkyl, the value is 30. Chlorine and bromine, 5 each, and N is 60 nanometer. Okay, you can refer to this table. This one you're going to use in your calculation, final exam, and also exercise by referring to the appendix here. So you need to determine the parent value first, which whether it is the homoannular or heteroannular, and then by look at the figure of the compound, you need to determine the double bond extension to diene system. Kalau ada lah, kalau tak ada, just keep diene system within a ring. Don't need to find this one. Don't need to find exocyclic nature of double bond in conjugated system. Yes, you must find this one. Each alkyl substituent or ring residue. Okay, then the other name for ring residue is alkyl substituent. And the last one is the ozochrome. So that's all for diene system. Now we proceed with some example. Students tend to get confused to determine the exocyclic double bond. So let me explain more about the exocyclic double bond. So you don't need to worry about the endocyclic double bond because we don't have the value for that. And it's a bit confusing for endocyclic double bond. You just need to know where is the placement of exocyclic double bond. Look at this structure. Okay, outside the benzene ring here, there is one double bond attached to it. So we call it as the exocyclic double bond. So in this compound, it has one exocyclic double bond. Value is 5. Now we look at the example 1. We have A compound and B compound. So outside A compound is B compound. Is there any attachment of this green line to the A compound? So please make sure the A compound is 6. Ada 6 apa nama? 6 line kan? Sorry. 1 hexane. Aromatic 1, 2, 3, 4, 5, 6. So is there any attachment of the green line to the structure? No, right? Kalau dia nak attach, whether it will attach like here or like here or maybe like here. So we can assume there is an attachment of the structure to the compound. So there is no exocyclic double bond outside A. While we look at the exocyclic double bond outside B. So you need to cover structure A. Now we look at the red one, the red line here. Outside B, there is the red line attached to the structure of B here. Kan? Nampak kan? Yang color merah ni dia attach dekat structure B ni. Melekat dekat sini. Sama ada yang merah ni dia boleh duduk sini. Kita kira dia sebagai exocyclic double bond outside B lah. Sama ada dia duduk sini ataupun dia duduk kat sini ataupun dekat sini. So we consider it as exocyclic double bond. Untuk yang green color, it is located far away from A because it is separated by single bond here, so we cannot say that it is exocyclic. So this structure have one exocyclic double bond. The second example, okay, we look at A structure and B structure. So outside the A compound, is there any attachment of double bond to that A compound? Yes, it is. It has 2 exocyclic double bond attached to A compound, which are one here and the other one is here. So 5 times with 2 is 10. So outside the B compound, we have A compound. So there is no double bond inside A compound. Look at this third example. Compound A and compound B. Outside compound A, there is one double bond, which is exocyclic double bond. Outside compound B, there is also double bond outside compound B. So we assume that there is 2 exocyclic double bond, right? So for this compound, 2 exocyclic double bond. So exocyclic double bond have only one carbon as part of the